Greetings, what you're looking at is my new 4-inch slot MAF and K&N air filter I'm going to put on my 95 Mustang. This was a part of my plan to give my old Mustang a new lease on life. I'm going to put a new larger engine with higher horsepower in the car, and obviously I would need more airflow than the stock sensor would probably be able to deliver without pegging. At the time I was doing my research, everything seemed to indicate that I was going to require a 4-inch sensor housing to handle the horsepower I anticipated. Since then, I've since discovered that a 3.5 or even 3-inch housing would have probably done the job. In this video, I'm going to show you what problems I ran into with my much larger housing with underhood air. I actually ran into thermal problems with the mass airflow sensor, but we'll get into those just a little bit later. All the research I did showed that the slot MAFs were better than the old style MAFs from 95 or even the early 2000s. This is one of the first generation slot MAFs I have installed here. I also have a second generation slot MAF like is currently installed in the new cars, and I'll be installing and testing that in a later video. First, let's get into a little background. We'll take a look at the stock setup, and then we'll take a look at my new 4-inch mass airflow sensor with the slot MAF setup. Well, here's the stock setup before I begin. Obviously the air cleaner and the mass airflow sensor. I'll be retaining this elbow here. Here's where my new connector will connect in, and we'll take a look at that in just a minute. Here's the new setup. The air cleaner is from K&N. Their part number RG1001 RD-L. You can also get them in white and blue if you want different color air cleaners. This is the actual sensor housing. It does have an air straightener in the housing. This is off of eBay. The actual sensor itself, again, off of eBay. This is about 80 bucks. This is about 30. This cable itself is about 50. Cable came from VMP Performance. The actual sensor is about $20, again, off of eBay. And this end will plug in exactly where my other end was before. Here's the stock housing looking from the engine end back. Obviously there's a large rib running right down through the middle that encloses and protects the hot wire. The actual housing is 70 millimeters inside diameter. Here's the new housing, 95 millimeters inside diameter, obviously much more open and free-flowing. The air straightener helps clean up the airflow going into the sensor, which by in itself is a better and more accurate representation of the actual airflow going in the unit. A 4-inch housing does not appear to be a major problem with accuracy with the MAF sensor, at least not with the first generation sensor. I was getting good repeatability throughout the RPM range with this sensor. The only exception was a thermal issue that I encountered on very hot days, which is what we'll look at next. This is a data log taken from Clint Garrity's binary editor software as being run on my Modes quarter horse, both excellent products by the way. The yellow line is engine RPM. The pinkish line is mass airflow in kilograms per hour. The red line is air charge temperature, the actual temperature that the engine is seeing underneath the hood. Note that air charge temperature is at 94 degrees. The mass airflow sensor has a good, solid, stable signal, and the engine is at idle. All of that is determined at the point on the screen where the white line crosses all the other lines. Here's where I ran into trouble. The colors here are the same. The condition is the same. The engine is at idle. The main difference here is that the air charge temperature is 170 degrees under the hood. The mass airflow sensor is reading much, much lower, and the engine RPM remains the same. Clearly the mass airflow sensor had virtually stopped working on me at these higher temperatures. Under these conditions, the engine would surge and buck. It barely would idle. It wouldn't accelerate. In general, it acted like it was not getting any fuel at all. And of course, as far as the mass airflow sensor was concerned, it wasn't getting any air. This was with the new mass airflow sensor and the air filter installed in an open engine compartment. Clearly this wasn't going to work on a very hot day where you were idling the engine in traffic and your underhood temperatures could get above about 120 degrees. After that, the mass airflow sensor started having problems, and the car was becoming undrivable. I clearly had to do something to isolate the incoming air from the engine compartment and pull in cold air from the fender as the stock setup did. Clearly the Ford guys knew something that I didn't, but I definitely learned. After thinking it through for a while, here's what I came up with. First step is, of course, to establish a base point for measurements. That's what this piece of cardboard with all my scribbling on it dictates. Basically, I leveled this piece of cardboard up underneath the hood and then started pulling dimensions off of this cardboard. The front end turned out to be self-supporting with all the air conditioning hoses. The back end, well, I had to rig something up. Here's another couple of views of that datum board. Note that the air conditioning test port worked very well to support the front of it and help keep it level. Now that I've got my starting point, the next trick, of course, is, well, how do I get dimensions underneath the closed hood? Actually, that turns out to be pretty simple. In 2 words, Play-Doh. You just mold the Play-Doh into shapes you know will contact the hood after some preliminary dimensions. Close the hood and note how the Play-Doh is deformed. Play-Doh is great for this application. It's very easily moldable, very soft, not sticky, and pretty darn cheap. You should be able to find it at a good toy store like Toys R Us, or you can order it over the internet like I did. The next step is to make up a thin cardboard template, and here's what that looks like. Now that I've got my template, it's time to transfer it to the actual material. In this case, this material came from a Master car. Their part number is 93265K46. Low temperature polyethylene foam rubber insulation, 1/2 inch thick, 36 inches by 48 inches in black. And it's good for over 200 degrees. Next step is to make up 2 more templates, one for the front and one for the back. Here we see the one in the front. Again, the best way to do this, just take a piece that's a little bit larger, a good sharp pair of scissors, and keep trimming till you get the shape you want. And here's the other template in the back nearest the firewall with the 4-inch diameter hole cut into it for the MAF sensor to go through. And here's my first completed prototype. It is held together with liquid nails. I use safety pins to hold it in place while the adhesive had a chance to sit. This acts like a support for the MAF sensor on the inside of the unit, and obviously this hole is where the MAF sensor goes through. These 2 sides go up against the top of the hood, as does the top. This side comes in just below the air conditioning pressure switch, and the bottom rests against the bottom of the car, leaving the entire side open for air to come in on this side. This is pretty much complete as I'm going to install it in the car. I'll probably go back and paint it just to give it some weather resistance, because this stuff doesn't do too well if you expose it to a lot of moisture, sunlight, and humidity, but it'll stand up pretty good if it gets a coat of paint. So that may be the only thing I do before I put it in the car and give it a try. Here's what it looks like with the airflow sensor housing in the air filter as it would be installed in the car. You'll note that there's plenty of space around the air filter for the air filter to breathe. And I'm anxious to see how well this does. This definitely should solve my temperature problems I was having with the air mass airflow sensor. Here's a view of the cold air box that's installed in the car without all the hardware. You can see it fits pretty easily around the alternator, and it's grouped around the air conditioning sensors. Here's my completed cold air box. The only difference between the initial video where I showed you just the bare box is it has been painted black on the outside for some weather resistance. The cables are all hooked up. The air filter is in place. And this is the finished product. I'm going to take it out for a test drive. I've had several of you tell me that I sound like Elvis, so thank you. Thank you very much. Thanks for watching. Check back often. I got lots more coming. Take care, man. Be good.